Hello everyone, welcome back to Believers IAS Academy. This is Prelim Hack series, a topic of the day series. In this, I will be discussing a short topic, that is fluorescent nanodiamonds or FNDs. Very important topic, especially from the science and technology part of your prelim series syllabus. There are many current affairs which are related to the static part. They are asked in UPSC prelims. So I have taken this topic as your discussion. What is fluorescent nanodiamonds? These are a nanometer sized diamonds formed from carbon nanoparticles. So it is a nanomaterial. Keep that in mind. How it is created? These nanodiamonds are synthesized through a process involving high temperature and high pressure to alter carbon atoms arrangement into diamond structure. You know that, right? Carbon is the basic content behind or the component behind both coal as well as diamond. The difference is at the pressure or the heat at which carbon is heated. Okay, they say that if the coal or charcoal or coal is heated at a extremely high temperature and is subjected to pressure, it converts into diamond. Okay, so many of the times diamonds are also found in the coal reserves only. Okay, so that is another discussion. Then properties of FNDs are known for their stability under light, being non-toxic and having a long fluorescence lifespan. Okay, then applications in various fields. Medical diagnostics. FNDs are used in detecting and tracking biological molecules or cells. And then microscopy, that their fluorescence properties make them ideal for imaging at microscopic level. And temperature sensing. FNDs can be employed to measure temperature with a precision. Very important applications. There can easily be a question on fluorescent nanodiamonds and its applications related to it, and there can be 5 applications, and the question will be how many of the above applications are possible from FNDs. 1 only, 2 only, 3 only, 4 only, that kind of questions. And they are also used in biological use, that is FNDs are commonly used in biological research to track and monitor the movement of cells over the long periods thanks to its stable fluorescence. Okay, and about the unique fluorescent properties of the FNDs, how the fluorescence is emitted. FNDs emit light at a lower frequency when exposed to higher frequency light, which is a property called as fluorescence. That is, they emit light from themselves by absorbing the light from other side. Okay, then non-blinking nature. Okay, unlike many other materials, FNDs do not blink. Very important. That is, blinking is they stop emitting light intermittently. They will emit and stop, emit and stop. Whereas these fluorescent like diamonds, they continuously emit the light. They do not blink. When irradiated over time, this makes them more reliable for long-term observations. Okay. Then fluorescence lifespan. The fluorescence lifespan of FNDs exceeds 10 nanoseconds, making them superior to other materials such as quantum dots, which often exhibit shorter lifespans. Very important. Most of the times we associate quantum dots with all the possible, we associate quantum technology or quantum dots with all the possible positives. If there is any positives, if there is any extraordinary achievement, that is associated with quantum dots. Not the case here. Quantum dots have a shorter lifespan compared to the fluorescence of FNDs. Very important. There can easily be a statement about FNDs or the quantum dots relating or comparing their lifespan here. Okay, exceeds 10 nanoseconds, which makes them superior for the compared to nanodots. About the quantum spin and the Berry phase. What is quantum spin? In quantum mechanics, spin refers to the intrinsic angular momentum of particles such as electrons and nuclei. There is an angular momentum, they keep rotating at the angular, that is called as quantum spin. Electron spins can exist in 2 states, that is up or down, and manipulating these pins is fundamental for quantum computing. Okay, then the Berry phase. Berry phase is a phenomenon where the phase of the wave, such as an electron, changes as it passes through different states or experiences external influences. Very important. This phase is important for understanding the complex quantum effects and can help reveal the properties of materials like topological insulators. Okay, understand the difference between quantum spin and Berry phase. Very important. You can pause the video and read them again. Quantum spin, electrons and neutrons are revolving at angular momentum. Berry phase, the phenomenon, it is a wave phenomenon that electron or any other like neutron, proton, etc., they change their their wave changes as they passes through different phases of the quantum. Okay, so that is the Berry phase and quantum spin. Then about the applications of FNDs in the industries. In advanced sensors, that is levitated FNDs are extremely sensitive to the external forces such as acceleration and electric fields, making them promising candidates for use in highly sensitive sensors. Then gyroscopes for rotation sensing. The Berry phase generated by the rotation of the levitated FNDs could be applied to create gyroscopes, which are devices used to measure rotation and the orientation. Okay, now you know that Berry phase, when the states change, the electron, etc., changes their characteristics. Similarly, if these FNDs are made to go through the Berry phase, they keep on changing with the states. That property can be used in gyroscopes, which is a device to study or measure the rotation and orientation. This could revolutionize industries requiring precise rotational measurements such as aerospace, robotics, and navigational systems. Very important, FNDs and importance in aerospace, robotics, and navigation systems. So that ends our discussion for the day. Very small topic but very significant topic from UPSC prelims. You can expect a question similar to this in your prelims this year. So write important points about FNDs. With this, I will end the video. Jai Hind.